Global warming is a major problem. It causes melting polar ice caps, rise in sea levels, loss in biodiversity. That makes it one of the grand challenges for scientists and engineers alike. We now know that the main culprit behind global warming are greenhouse gases like carbon dioxide. So, one idea to mitigate global warming could be by capturing large volumes of greenhouse gases from the atmosphere and storing them elsewhere. Where exactly do you store? Well, probable locations could be underground mines, underground geologic structures, any abandoned natural reservoir with large volumes of void spaces inside, exactly like the one you see on the figure to the left. This idea looks good, except the fact that all of these natural structures are inherently porous. This means the gas that's typically stored under high pressure has a tendency of escaping through the network of microscale pores all around. So, for this technique to work properly, one must ensure a reliable sealing strategy. The good news lies with tiny little bacteria cells, the ones I work with, Sporosarsina pasteuri. If you provide them with the right chemical environment, these cells can produce tiny solid crystals. These small particles, like powders, can actually go inside the pore network and cause clogging. As a result, the structure gains dramatically in mechanical strength. This is not really different from icing a cake. You pour the cream on top, it drips, trickles down, and fills up the voids. This is exactly what I'm trying to do using nanotechnology. In case you are wondering what that means, imagine one single human hair. Now, shrink it by 100,000 times. That's about 1 nanometer. My technology works at this small length scale. Using state-of-the-art nano tools, I am building what are called nanofluidic chips. These are small handheld platforms that very precisely and accurately mimic the real underground porous media. Now, by taking my bacteria and injecting it inside the chips and using advanced microscopy, I can actually observe the fluid going inside the pores and causing the blockage. These experiments give me key insights into the several physical, chemical, and biological aspects associated with the process. Armed with this knowledge, I am trying to design robust sealing strategies which are clean, green, and eco-friendly. So, using my research, I'm trying to make the concept of long-range, long-term, safe underground storage of carbon inside natural reservoirs a reality in near future. In this way, through my research, I am trying to mitigate global warming in the long term and make planet Earth a better place to live in. Thank you.